Hey, hello, and welcome to the show. It's me, John Park, who's now turned on his microphone. Thanks for the heads up. This is it. This is the finale. This is the final product pick of the week for 2025. I think it's also one of our last live streams for the year. I'm not sure if Foamy Guy or Scott will be doing a deep dive tomorrow, but this may be it. And I thank you for stopping by. We've got some people over in our YouTube chat. Hello to Bleemer and Gordy G, Beata Graf Abdelhagen, as well as Peter Huseman. Hello, thanks for stopping in. And look, that's our Discord chat right there. Hello to Paul Cutler, Thin Man, Jim Hendrickson, hello. And Sam J. Ohio, hello. Hey, Starman. Thank you. Thanks for popping in. This is it. This is going to wrap up my Adafruit live streams for the year. So thought we'd go out with a bang with a pretty fun one. And as is customary on the show, I'm not going to tell you what it is, but I will give you a hint. If you go there, that's it. That's it right there. So if you know your product ID numbers really well, then I just spilled the beans. Product ID 1048. You can also use that QR code to head on over there. And this show is broadcast from inside the chat, so you can stop by and look at the product, pore over the beautiful photos, and still watch the show. And we've got this one for a 50% off discount, as well as a bunch of related things. I'll show you all that in a moment. We've got a little bit of intro to it going way, way back. This actually is from 2012. So I'm going to let Lady Ada of the past tell us all about it. Take it away, Lady Ada.
The beautiful little backpacks that you made. These matrix backpacks.
Yay!
So photo of the front and back, so you can see, but they're gorgeous, and I really like them. You want to go to the overhead right away?
Yeah, I can show off what the thinking was, and I can.
Okay, let's go to the overhead.
So the thinking was that we had these little 8x8 matrix displays, but the problem with them is they have 16 pins that you have to control. And another problem with that is not only do you have 16 pins to control, but 8 of them you have to digitally control to control like one row. And then you have to sync all of those at the same time. So you need to have like a powerful 100 milliamp transistor to short the common anodes or common cathodes, whichever one you decide to use, to power ground. So you can't just connect all 16 to a microcontroller and hope it goes. It's actually not really good for the microcontroller, and they won't be very bright or good looking. So you can use chips like the Max 7219, but they're kind of expensive and they're really big. Like the chips are like this big. So you have this gigantic chip and a cute little matrix, and that kind of sucks. You can do it with 595s, but then you have like 3 chips before you know it. And there's a lot of wiring and it's kind of annoying. A lot of people have trouble with them. So I thought I wanted to create some sort of backpack that would go on the back of them. And this is the same matrix. And the backpack would have a chip that does everything for you. And so I tried out a whole bunch of different chips. There's a couple different chips on the market that can do this, and I actually found this one worked the best. This is a Holtec chip. They actually are really good at making LED matrix drivers. Their more popular chips are like the 1632. They also make some encoder chips and stuff, but I've used Holtecs for a while, and they're really good. The only problem is you have to buy direct from the distributor. They don't distribute the DigiKey or Mouser. So this is a chip on the back, and it's a constant current LED driver chip, and it's basically designed to do exactly what is shown here. You connect it up to a matrix, and it has I2C, and it's really easy to use. So I have it hooked up here to an Arduino, and I have 2 matrices together, and I'm going to power this with my ginormous battery pack. So this is a yellow and red. I also have a green one over there. And this is just showing a demo. And these are actually both connected on the same I2C line. So you can connect up to 4 of these on one line. There's an address select pin on the back, 2 pins on the back, so you can change the address. And it's really easy to use. Like we have a library, so you can set the pixels, draw lines and squares and little bitmaps and stuff. And basically it means that you can control this matrix using the I2C lines on any microcontroller really easily. And they don't add a lot of space, and they add little mounting holes, so that's really good too.
And yes, that did abrupt end. That was all that was said about it in that show. So, but look, let's get on with it. And then we got some demos. So this right here is the product pick of the week this week. It is the 1.2-inch 8x8 LED matrix backpack with STEMMA QT. This is a single color LED driver. So we have some different ones that do bi-color and ones that do segmented displays. But this is for either dots or squares, 8x8 of them per board. You can control this in Arduino, you can control this in CircuitPython, you can control this with Python on a like a Raspberry Pi using CircuitPython and Blinka. We've got a couple of STEMMA QT ports there, so you can plug that into your microcontroller or small board computer and drive that with just 2 pins. So if you look at the back of one of these, like Lady Ada said, there's a bazillion pins on there, and that is not easily driven from a microcontroller. You can't just plug those into GPIO pins. So this is what you want to drive these kinds of displays. If we take a look at the site right here, and let me bring up my little handy dandy overlay, you'll see these are $3 right now, so half price. We had, I think, 150 or so in stock, so there should be plenty to go around. You just want to throw them in your cart and buy them. There's no coupon code or anything like that. We're just going to put the price back up after the show. And huge thank you to the new products team for handling that, by the way. Everyone's trying to wind the year down, but I really appreciate the support. And if you take a look here, you'll see we've got a link to some of the different displays you can put on this. So here are lots of different colors of either the dots or the squares. And this is just the single color ones like I mentioned. If you follow these links off to the side, you will hit a whole bunch of them. So we've got blue, we've got yellow, green, green, white. Here's blue in the square, orange, yellow, orange, green, white. These are pretty good little STEMMA QT connectors to use if you want to do multiples of these, because there are 8 different addresses available for this on a single I2C bus. You can gang up 8 of these using the 3 address jumpers on the back. I'll show you that in a moment. And you can take a look at this Learn guide right here. It covers a whole bunch of different LED backpacks, but the first one here is this one, the 8x8 matrix. And what you can do with these, of course, is light up any of the individual pixels on there, either on or off. And you can control the brightness, 16 levels of brightness for the whole display. You can't do individual pixels, but the whole display, you can dim that or brighten that, either just to set it and forget it or use that as an effect. And you don't have to stick to one color. I'll show you in my demo. I've ganged up a whole bunch of different colors of these, which is fun. But they're really a great looking display. And what I want to do is jump to my overhead view here. And here you can see a whole bunch of them. I set up 6 of these. I'm driving those with a little Cutie Pie RP2040. And I 3D printed a little holder just to put them in a little arc here. And this is one of the neat things about them, is that you do not have to constrain these to a rectangle. You can put these at angles, so it's a little different than a typical skinny display. You can bend something like this to sort of do a 3-dimensional shape. These are great for costume effects, little props, robots, that kind of thing. If we put a little LED diffuser on here, you'll see the color's a lot better, just because my camera doesn't want to deal with those bright LEDs. This fuzzes them up a lot, especially on camera. They're a little sharper in real life. But it lets you see a little better some of the different colors we have here. So I happen to gang 2 of the yellow-green ones here. I really like that color on the end. This is the yellow-orange, the blue, the green, and the red, and I have a white one that I didn't hook up. So those are a whole bunch of colors there. And if we take a look at the code for this, let me bring up Zed. This example that I'm doing is actually straight from the Learn guide. So we have example code for this. This one allows you to set a individual display by default. This will be on address 70, and so you'll see the first one that I have plugged in here. That one's set to address 70. And don't let me forget, I'll show you what the jumpers look like for that, for adjusting those. And so if I take my code here and set it to, let's say, the second one on here, address 71, you'll see the second one will start going. The code for this, I have these all kind of sideways just because of the effect I was going for. So the origin is actually upper left corner. That's the first one that lights up. So you can see this is a HT16K33 driver. So we'll import that, the matrix portion of that library, and then I'll set up a matrix using the matrix 8x8. There's a few different variations inside of that library on the I2C bus and picking an address, which you can leave that off if you're using the default. And then the first thing I do is fill the matrix, set that to 0. If you look here, if I just change that to 1, then this will go full green to begin with, and then the other stuff kicks in. So the fill command just immediately writes all of the pixels, and then you can address them individually. So matrix, and then 0, 0 would be the origin, 7, 7 would be the opposite corner, and anywhere in between. So you can set up a little bit of convenient program, little convenience in your program here for columns and rows, and address those. Set up little patterns, and then the library allows you to do a whole bunch of other interesting things, like once you've drawn something, you can shift it around with a shift command rather than having to redraw it, and that's what's going on in the main loop. Is we just draw this smiley face, and then we're shifting it, pausing, shifting, pausing, shifting, pausing, and that's what's driving this all around. If I take some other code that I set up here, I'm going to copy and paste that into my code.py. I'll put the diffuser back on here. So here's a nice little sort of sparkles effect. And in my code here, which I will admit I worked with Claude AI to develop these demos, most of it coming from our example code, but kind of mushing them together into a single demo program. I used Claude to make that easier. So I've got, if I go ahead and allow all of those to run, we're going to see one demo after another here. So initially I'm turning them all on, blink that off, running a little wave vertically down it, and then a wave across it and back. Set some little raindrops here flowing, and then a little sparkle like you saw earlier. Oh, my USB just made it all restart. So now we get it again from the beginning. So please bear with. Hi, Dave Odessa, who just showed up in the chat. So here's a little raindrop demo, and then I'm running a single pixel around the perimeter of it. Since I combined these 6 displays into one, I wanted to see what it looks like to run one across. Oh, was it getting stuck on rain? There we go. There goes the raindrops. I think I had a long delay on that. Here's the sparkle. There goes the perimeter running across all of those. If I lift that up there, you can see what it's doing. And then a little text for you. Happy New Year. So I'll go ahead and run that one on its own real nice and big because I think that'll look cool. Let's resave that. Happy New Year. And you can do other effects like sliding those around individually, or write a little code around, a little wrapper around that to slide them as a group across there, marquee style. So that's the little set of demos I wanted to show you. Let me give you a nice little close-up here of the board. So if you look, let me take that off of there. If you look in the photo on the top there, between the two STEMMA QT ports, there's a set of 3 jumpers, A0, A1, A2. So normally this is address 70. If you solder a little blob across the A0 pads, then this will be 71, A1, 72, A0 and 1, 73, A2 by itself, 74, A0 and 2, 75, and so on. So that's what I've done on all of those there to give them different addresses. Beyond that, you don't have to use the STEMMA QT cable and ports. You can use the serial clock, serial data, ground, and VCC that's off on the side. And then those other 16 solder pads there that you'll see on the back. Those are for your display, and we have some nice instructions in the Learn Guide of how to orient these. There's a little silkscreen dot in the bottom corner there, and these displays have text on just one side. So that's how you know that you've got it in properly. You could potentially give this a little squeeze to make contact and fire it up and make sure that it's oriented properly. But as long as you follow the Learn Guide, you'll be able to get that right and solder those in, and then you can clip those off. We do have some mounting holes on here, and that's how I connected these up here. If I turn up my exposure a bit there, I made some little 3D printed, I didn't want to deal with M2 screws and nuts and things like that, so I just made some little posts to slide these over here. So you've got 4 of those. I just made 2 posts to keep this kind of oriented just for the demo. But you can mount those any way you see fit to anything you want, except for the cat. Don't mount it to the cat. All right, what else? Am I forgetting anything? I think those are all of the little demos and things. A reminder, if you want to go pick one up, head here. They are $3. They are still in stock. And the stock counts will vary on the different colored displays. So you'll have to look and see which are available for those. And those are also half priced. So if I failed to refresh these earlier, let me just show you. If I head back to these and refresh, you'll see we got 2 of these in stock and they're half price. Those are in stock. Oh, out of stock. So that one's gone now. Yes, a lot of these were. Oh, that came into stock. 96 of them. There were, I thought, just 2. Okay, yeah, hey, all those. Okay, yeah. Thank you again to the new products team. I know they said they were able to stash some of these, so some of these that didn't have many at the beginning of the show are now stocked up. And sorry, I didn't do a demo with the square ones. I just stuck with those circle ones because I had a whole bunch of colors of those laying around. All right. Well, I think that's going to do it then. Let's see if I can lift this thing up and not have it all fall apart on me, and we will wrap it up. That right there is my product pick of the week this week and the last one of 2025. It is the 1.2-inch 8x8 LED matrix backpack with STEMMA QT. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you next year. Thanks everyone so much. Bye-bye.